Hey guys, so here's what we've got today. We've got our convection tube set up. We've got in this one the cold surface is represented by the cup of ice with the cool water, and on the left we have the candle represent a warmer hot surface. Now we've gone ahead and we've made predictions about how the air might behave when they're connected. We know for sure how it's going to behave individually. So in this one, we've already seen the cold air sink. It becomes very heavy, very lethargic. It doesn't move around, and it looks very thick and very dense inside there. Okay, now in this one, when it was by itself, the air seemed to move very quickly. It had lots of energy. It was very wispy, and we all saw it come up and out of the tube. Okay, so now that the tubes are connected, we've made some predictions about how it should behave, provided we can see what the air is doing inside. So I'm going to start off by introducing some air highlighter with this punk into the hot, and we'll see if our prediction is correct. So here we go. Smoke in the convection tubes with the hot surface. Again, this is the hot surface. So what I'm seeing, and I hope you guys can see it too, is that the smoke, the majority of it's going just straight up and out. Now there are smaller wisps that are sort of making it down to about this far, but as soon as it gets to about here, it's back up and out with it. I can go even lower and see what happens there. Still pretty much the same thing. Okay. Now into the cold convection tube. Okay, here, what's happening is the smoke's not even making it past a certain point, and it just seems to be falling and pouring and filling into this bottom cold convection tube, just like we saw when it was by itself. Again, but this lab is looking for what happens when the two are connected. So this is filling up more and more and more. The air looks just like it did before, and I don't know if you can see here, but the air is flowing, it's pouring into this convection tube on the left. Now once it gets in there, it's doing the same thing it did when it was by itself. The air is moving very quickly, it's swirling a lot, and then it's coming up and out. Alright, now if I move the light, you guys might be able to see the smoke coming up and out of the convection tube up at the top. So if I move this punk stick, air is coming up and out of just the one on the left. Right? So we have this movement down, over, around, and up and out. I'll introduce the smoke again so you can see it. And again, watch how it sort of like falls and fills and then pours over into this hot surface convection tube. You see it sort of getting darker and thicker in here. Fills up, and then it pours into here, hits this heat, and then there's this heat transfer in both of these tubes. In this one, we've already talked about this, but the heat transfer is going from the warmer air to the colder ice, so that heat energy is being shared with the colder thing in this scenario. And in this scenario, it is the ice. So hot air to the colder ice, and as it does that, it becomes more dense and falls because it's getting so much heavier. And as it does that, it fills up like the water in your sink. It hits that point of least resistance and then flows over into this hot surface. Now in here we have the opposite of heat transfer. That candle is introducing a whole bunch of heat energy into the colder, heavy air that is pouring in from this cold circumstance. Once it has that extra energy, the air molecules get excited, they expand, they need more room, they're bouncing off of each other, and they are moving like they're actually excited with energy. And as they do that, they're moving up. So it's from here now that we have to figure out what causes this current. What is it about this setup that makes the air in here sink, move over, and then come out?